Have you ever wondered why the oldest buildings in your town are still standing while the houses built just 30 years ago are crumbling? This is not a coincidence, and it is not nostalgia speaking. There is a measurable scientific reason why farmhouses constructed in 1890 are still sheltering families today, while homes built in 1990 are already falling apart. The answer reveals something profound about how we have fundamentally changed the way we build, the materials we choose, and the relationship we have with permanence itself. By the end of this video, you will understand that the decline in building quality is not a matter of opinion. It is documented in engineering reports, construction standards, and the very bones of the structure. Let us travel back to the 1880s and 90s in rural America. The Industrial Revolution had transformed manufacturing, but it had not yet transformed the way ordinary people built their homes. A farmhouse built in 1890 was constructed by a carpenter who would likely live in that same county the rest of his life. He knew that his reputation depended on every nail he drove and every joint. The wood he selected came from trees that had been growing for 100 to 200 years. These were old-growth forests, trees that had survived countless seasons, droughts, and storms. The wood from these trees was dense, tight-grained, and naturally resistant to rot and insects. A single beam from an old-growth tree could support weight that would require 3 modern beams to match. The construction methods of that era were born from centuries of trial and error. Carpenters used techniques that had been refined through generations. Mortise and tenon joints, where wood pieces were cut to interlock without nails, created connections that actually grew stronger over time as the wood settled. The foundations were built from stone that had been quarried locally, often from the same land. These stones were fitted together with lime mortar, a material that was softer than the stone. This might sound like a weakness, but it was actually brilliant engineering. When the earth shifted, the softer mortar would compress slightly rather than cracking the stone. The entire structure could move and settle without catastrophic failure. The roofing materials in 1890 were typically wood shingles or slate. Slate, a metamorphic rock that forms over millions of years, is one of the most durable materials ever used in construction. A slate roof installed in 1890 could last 300 years or more. Wood shingles, when made from old-growth timber and properly maintained, could last 80 to 100 years. The nails used were hand-forged iron, which actually improved with age as they oxidized and bonded more firmly with the wood. There were no shortcuts in 1890 because there were no alternatives. Every material had to be sourced, prepared, and installed by hand. This created a natural incentive for quality. Now, let us jump forward to 1990. The world had changed dramatically. The old-growth forests of North America had been almost entirely harvested. The remaining timber came from second-growth or third-growth forests, trees that had been growing for only 40 to 60 years. This younger wood is less dense, more prone to warping, and more susceptible to insect damage. The construction industry had become industrialized and standardized. Building codes existed, but they were designed to establish minimum acceptable standards, not optimal ones. A house built in 1990 was often constructed by workers who would move to the next job site the following week. There was no personal stake in the long-term durability of the structure. The materials used in 1990 reflected this shift toward efficiency and cost reduction. Dimensional lumber, cut to standard sizes like 2x4 and 2x6, had replaced the massive hand-hewn beams of the previous century. These standard lumber pieces were often kiln-dried, a process that removes moisture quickly but can weaken the wood, creating internal stress. The joints were no longer mortise and tenon. Instead, they were simple butt joints, held together with nails or screws. These connections were faster to make, but weaker and more prone to failure as the wood dried and shifted over time. The foundations in 1990 were typically concrete, a material that had only been widely used for a few decades. Concrete is strong in compression, but weak in tension. It cracks easily when the ground shifts, and once cracked, water can penetrate and cause further damage. Unlike lime mortar, which can self-heal to some degree, concrete cracks are permanent. The roofing materials had changed to asphalt shingles, a petroleum-based product that had been invented in the early 1900s. An asphalt roof typically lasts 15 to 20 years before it begins to deteriorate. The nails used were galvanized steel, which corroded much faster than hand-forged iron. But here is where the story becomes even more interesting. The building codes of 1990 actually allowed for lower quality construction than the codes of 1950 or 1930. This seems counterintuitive. We assume that newer standards are always better. But the reality is that building codes are often written by committees that include representatives from the building industry. There is an inherent conflict of interest. A code that requires expensive materials or time-consuming construction methods is less profitable for builders. Over the decades, codes have been gradually relaxed in certain areas while being tightened in others. The result is that a house built in 1990 was often permitted to use materials and methods that would have been considered substandard in 1950. Consider the issue of ventilation and moisture control. In 1890, houses were built with large gaps in the framing that allowed air to circulate freely. This prevented moisture from accumulating inside the walls. In 1990, building codes required that houses be sealed tightly to improve energy efficiency. This was a good goal, but it was implemented without adequate understanding how moisture moved through building. The result was that moisture became trapped inside the walls, leading to mold growth, wood rot, and structural failure. Many houses built in the 1990s began showing signs of serious moisture damage by the year 2010, just 20 years after construction. The issue of material sourcing reveals another crucial difference. In 1890, a carpenter would inspect every piece of wood before using it. Defective pieces were rejected and used for other purposes. In 1990, wood was graded by machines that could be fooled by surface treatment. A piece of wood with a serious internal defect might pass inspection if the surface looked acceptable. Furthermore, the pressure to keep costs low meant that wood was often used before it was properly dried. Greenwood, wood that still contains significant moisture, will shrink and warp as it dries. This creates stress on the joints and fasteners, leading to cracks and failure. The nails themselves tell a fascinating story about the decline in building quality. The hand-forged nails of 1890 were tapered, meaning they were thicker at the head and thinner at the point. This taper meant that as the nail was driven into the wood, it created a wedging action, pressed the wood fibers around it. As the wood dried and compression held the nail firmly in place. The modern wire nail, standardized in the 1880s and dominant by 1990, is cylindrical. It does not create the same wedging action. As the wood shrinks, the nail can work loose. This is why older buildings often have nails that are still firmly seated after 100 years, while nails in house from the 1990s often work their way out within a few decades. The concept of planned obsolescence, while most commonly associated with consumer products, has also influenced building construction. In the 1980s and 90s, there was a growing understanding in the construction industry that buildings did not need to last. The prevailing economic model assumed that buildings would be demolished and replaced every 50 to 70 years. This assumption fundamentally changed how buildings were designed and constructed. Materials were chosen based on their cost and ease of installation rather than their longevity. Structural systems were designed to meet minimum code requirements rather than to provide a safety margin for the future. The result was buildings that were optimized for the short-term profit of the developer rather than the long-term value to the owner. The story of the farmhouse built in 1890 and the house built in 1990 is ultimately a story about values and incentives. The carpenter in 1890 had a personal stake in the quality of his work. He lived in the same community. His reputation was his livelihood. He chose materials that would last because he believed in permanence. The builder in 1990 was often a corporation focused on maximizing profit. The incentive structure was entirely different. The builder would never see the house again after it was sold. The owner might discover problems years later, but by then, the builder had moved on to the next project. This pattern is not unique to residential construction. The same dynamics have played out in commercial buildings, bridges, and infrastructure across the developed world. A bridge built in 1920 might have been designed to last 100 years or more. A bridge built in 1990 might have been designed to last 50 years. The difference is not in the engineering knowledge available. It is in the economic incentives and the cultural values that shape the design process. The environmental impact of this shift is significant. A house built in 1890 that is still standing today has required minimal replacement of materials over 130 years. A house built in 1990 that requires major repairs or replacement after 50 years has consumed far more resource and generated far more. The assumption that newer is always better has led to a pattern of constant replacement and disposal that is unsustainable from an environmental perspective. There is also a psychological dimension to this story. In 1890, permanence was a value. People built things expecting them to last. There was a sense of stewardship, of building for future generations. In 1990, the culture had shifted toward disposability. Things were built to be replaced. This shift reflected broader changes in how we think about time, value, and our relationship to the physical world. We have become accustomed to the idea that everything is temporary, that nothing is meant to last. But the story does not end in 1990. In recent years, there has been a growing movement toward sustainable and durable construction. Some builders and architects are returning to principles that were common in 1890. They are using old-growth timber when available, employing traditional joinery techniques and designing buildings to last for centuries rather than decades. They are discovering that while these methods are more expensive in the short term, they result in buildings that are more valuable and more resilient over the long term. This is not nostalgia. It is a rational economic decision based on life cycle cost analysis. The farmhouses built in 1890 are still standing because they were built by people who believed in permanence. They were built with materials that were chosen for their durability rather than their cost. They were built with techniques that had been refined through centuries of experience. They were built with the expectation that they would shelter families for generations to come. The houses built in 1990 are already falling apart because they were built by people who believed in efficiency. They were built with materials that were chosen for their cost and ease of installation. They were built with techniques that prioritized speed over quality. They were built with the expectation that they would be replaced within a few decades. The question we must ask ourselves is not why the old buildings are still standing. The question is why we have allowed the standards of construction to decline so dramatically. What values have we lost in our pursuit of efficiency and profit? What would it mean to rebuild our world with the same commitment to permanence and quality that guided the builders of 1890? These are not merely technical questions. They are questions about what kind of world we want to live in and what kind of legacy we want to leave for future generations. The evidence is all around us. Walk through any old neighborhood and you will see farmhouses and Victorian homes that have survived 130 years or more. Now look at the subdivisions built in the 1980s and 90s. Many of them are already showing signs of serious deterioration. The roofs need replacing. The foundations are cracking. The wood is rotting. The difference is not in the skill of the workers or the knowledge of the engineers. The difference is in the materials, the methods, and the values that guided the construction. There is a famous saying in architecture: you cannot make a building that will last forever, but you can make a building that will last longer than you will. The builders of 1890 understood this. They built for permanence because they understood that their work would outlive them. They took pride in creating structures that would shelter future generations. The builders of 1990, operating under different economic incentives and cultural values, built for the short term. They created structures that would serve their immediate purpose and then be discarded. The implications of this shift extend far beyond architecture. It reflects a fundamental change in how we relate to the physical world and to time itself. In a culture that values permanence, we make different choices about materials, design, and construction. In a culture that values efficiency and disposability, we make different choices. The farmhouses of 1890 are monuments to a different set of values. They remind us that it is possible to build things that last, that it is possible to create structures that improve with age rather than deteriorate, that it is possible to make choices that benefit future generations rather than just maximizing short-term profit. The question for us today is whether we can learn from this history. Can we rebuild our relationship with permanence? Can we create economic incentives that reward durability rather than disposability? Can we return to the principle that the things we build should be built to last? The farmhouses of 1890 suggest that the answer is yes. They stand as proof that it is possible to build differently, to build better, to build for the future, rather than just for today. So the next time you see an old farmhouse standing for more than a century, take a moment to appreciate it. It represents a commitment to quality, a belief in permanence, and a willingness to invest time and resources in creating something that will last. It represents a different set of values than the ones that guided construction in 1990, and it raises a question that each of us must answer: what kind of world do we want to build? What values do we want our buildings to represent? What legacy do we want to leave for the generations that come after us? Now, I want to hear from you. In the comments below, tell me about a building in your area that has stood the test of time. What do you think makes it different from newer construction? What values do you think guided the people who built it? And if you found this exploration of how our buildings reflect our values' interests, please give this video a like and subscribe for more deep to the hidden stories behind the things we. Thank you for watching.